Yes, let's consider this problem. Let's just read this problem. Two identical pith balls, each carrying a charge q, are suspended from a common point by two strings of equal length L. The mass of each ball if Find the mass of each ball if the angle between the strings is 2 theta in equilibrium. So basically what we have is, we have a ball from which two strings are suspended, each of length L, such that at equilibrium there is an angle of 2 theta between them, or by symmetry I can state as an angle of theta and theta on both the sides. Now this is the separation and the system is in equilibrium. If the system is in equilibrium, firstly we need to calculate the separation between the charges. If we see this triangle, this length is equal to L and this angle is equal to theta, so this side becomes L sine theta. So from this part, this side becomes equal to L sine theta. The other counterpart also becomes equal to L sine theta, or the total separation between the two charges comes out to be equal to 2 into L into sine theta. Now if we consider the forces on each block, since the system is in equilibrium, the net force on each part would be equal to 0. What do we have in a net force? 1 tension, 1 mg and 1 F electrostatic, where mass or mg is required to us, such that this angle would be equal to theta by vertically opposite angles. In this equation again, if we break tension into two components, one would be T cos theta and one would be T sin theta as depicted in the picture. So T sin theta would be equal to Fe and T cos theta would be equal to mg. Let's actually divide the two equations. Let's do 2 by 1 this time because we require mg. So on dividing these parts, it would be cos theta by sin theta. There would be tension T at the top, there would be a tension T at the bottom, which would ultimately get cancelled out, is actually equal to mg by Fe. Else if I continue it on the next page, the expression which we got in the previous scenario was mg by Fe can be written as cot theta. M can be written as Fe cot theta divided by g, where Fe can be written as 1 by 4 pi epsilon naught. Charges on both the blocks as given to as q, so q square divided by r can be written as 2 into L into sin theta whole square. This is just the electrostatic force into cot theta divided by g. On simplifying this expression, I get q square by 16 pi epsilon naught into L square g. In the numerator I will be getting a term of cot theta, and in the denominator I will get a term of sin square theta. That would be the answer to this problem.